In this video, we'll learn that when we can say that a matrix is in row echelon form and when it is in reduced row echelon form also. So a matrix is in row echelon form has the following properties. All rows consisting entirely of zeros occur at the bottom of the matrix. For example, here we see that this row consisting entirely zeros and it occurred at the bottom of the matrix, the last row. Okay. Second condition is for each row that does not consist entirely of zeros. Okay, so this we don't have 0, we have 1, 2, minus 1, here we have 1. So the first non-zero entry is 1, called a leading one. So this is the leading one and this is the first entry. We don't care about zeros. Zero here is not a problem for us. Here we start with 1 also, this leading one, and this is also the leading one. Okay. Third condition is for two successive non-zero rows, like this row and this row, there are two successive non-zero rows. The leading one in the higher row is farther to the left. So the leading one in the higher row, this one, is farther to the left than the leading one in the lower row. We see that this leading one is farther to the left than the leading one in the lower row. The same here, this leading one in the higher row is farther to the left than the leading one in the lower row. Okay, so if those conditions are satisfied with the matrix is in row echelon form. Note that if every column that contains a leading one has zeros in every position, above and below, meaning here, for example, if we don't have anything above, no problem, the condition is satisfied also. If we have below 0, the condition is satisfied. If we have above also 0, the condition is satisfied, like this: 1 above 0, below 0. So above and below with zeros. Okay, and it has to be above the leading, the most important thing, above the leading one. Okay, or below the leading one. So the matrix is said to be in reduced row echelon form. Okay, one more time, just to be sure that, for example, here we see that this one has nothing above but below zeros, so the condition is satisfied. We continue, we come here, we have 1 above zeros, below all of it 0, so the condition is satisfied. Again here we have 1 above zeros, below zeros, so the condition is satisfied. And finally you have a row of zeros. This is not a problem for us, so the condition is satisfied, and we call this matrix as reduced row echelon form. Okay, let's see this exercise. Determine whether the matrix is in row echelon form or in reduced row echelon form, or neither. We see this matrix. I just take the pen. Okay, so we see we have 1. If we come down, we see that we have here also 1. First, this is not the first entry. 0, we don't care about the 0. We care about any number which is non-zero. So and the most important thing, it has to be 1, the leading one. Okay, we continue. Here we have 1 also, so the condition is satisfied with that. We have zeros below 1, nothing above, zeros over 1, and zeros 0 below 1, so the condition is satisfied. And here also zeros above 1 and nothing below, so this is in reduced row echelon form. Okay, let's see this example. Here we have 1, 0 under, below 1, and nothing above. We continue. First entry is 1, perfect. 0 over 1, nothing below. So, and those numbers changes nothing. Okay, the most important is this step. So it is in, B is in reduced row echelon form. Let's see this example also. We have 1, 0 below, nothing above, perfect. We continue. Here, you see we have -2 here, and this is a problem because it has to be 0, and we can say it is in reduced row echelon form. In this case it is in row echelon form. Okay, let's see this example. We have 1, and then we continue. We are looking for the first leading one. Okay, first entry with leading one, so it is here. Then we continue to the next step. Perfect, we found it, and we see that everything below 1 is 0, nothing above. Everything above, below 0 is 1, nothing above, 0 also above, and finally 1 and over 1 is zeros, and also below 1 we have 1, 0. So hence D is in reduced row echelon form. Okay, let's see this example. We have 1, we continue looking for the first one, leading one. We found it, and everything here we see everything below 1 is 0, are 0, and nothing above. Here we don't have anything. Here we have 1 over 1 is 0, below is 0. So this and this final row zeros, they are fine, nothing changed. So this is in reduced row echelon form. Okay, let's see this example. We are looking for first leading one, so first entry with leading one, so it is here. Then we are looking for 1, 1, 1, but we see that we have 1 here, right? Sorry. So we are looking for first entry with 1, but here is 1, but the problem is that the condition is always we have to have the first leading in the higher one leading, it should be farther to the left than the leading in the lower row, right? So this time it does not work, that's why it is in neither. Okay, let's see this example also. We have 1, we continue, we have a row of zeros, but we said that the row of 0, it should be at the bottom always. If we have a row of 0, it should not be in the middle or at the beginning of the matrix. Okay, it should be always at the bottom. That's why it is not in neither row echelon form or nor reduced row echelon form. Okay, thank you for watching.